Hello, in this video we will be talking about tectonic plate movement, but before we get into that, let's do a little history lesson. The idea of Earth movement came from the scientist Alfred Wegener. His hypothesis was all the land masses that we know today used to all be conjoined, calling it a supercontinent known as Pangaea. One of the evidences supporting this claim is that you can see on a map that the continents can fit together like puzzle pieces. And not only that, but if you look at the Appalachian Mountains, that mountain range also matches up with the British Isles and the mountain range in northern Scandinavia. Let's refresh on some vocab, starting with lithosphere, which is the outer part of the Earth's crust. It is known to be brittle, but also the coolest part. That sits on top of the asthenosphere, which is part of the upper mantle. It is significantly hotter, which makes it viscous. I know we recognize this map from early in the semester in Module 2, but this shows not only the borders of each of the plates, but also in what direction they move. We have divergent, plates move away from each other, convergent towards each other, and transform. They slide past each other. Now let's get into the forces that make this movement happen. It is common knowledge that heat rises and cold sinks. If you boil a pot of water, the water at the bottom of the pot will be heated faster because it's closer to the heat source. When water molecules heat, their energy and viscosity rises, which brings the heated water to the top of the pot. Colder water on top starts to sink because the water molecules are denser than the heated water molecules. This turns into a cycle. The cycle and motion is what happens in the asthenosphere below the lithosphere. This is called the convection current, and this current drives two forces that happen to the Earth's crust. The first force that we'll talk about is called slab pull. This is caused by the cooling portion of the convection current. If we are looking at where two plates meet, as the viscous rock in the asthenosphere is flowing underneath the plate, it pulls the plate with it and slips under the other plate, pulling it into the asthenosphere. Hence, slab pull. Think of it as a conveyor belt. When you're at the checkout in the grocery store, you put your items on the conveyor belt and the belt moves. The belt is the asthenosphere, and the items are tectonic plates. But with tectonic plates, they get pulled underneath with that conveyor belt. We find this happen in trenches, such as the Mariana Trench. The other force is called ridge push. This is caused by the heating portion of the convection current. The rising mantle pushes up the plates, and gravity does its part in helping separate those plates. We see this happen at mid-ocean ridges, where new crust is made, pushing the seafloor to move and to extend, making room for that new crust. Another place we see it is rift valleys. This is above water. The new crust comes up between the two continent plates, and if it becomes wide enough, it can turn into water channels. So here's a recap. Convection current is a cycle of hot mantle matter rising and cold mantle matter sinking. Slab pull occurs during the cooling portion of the convection cycle. It happens between convergent boundaries, meaning they are moving towards each other, and the Earth's crust is pulled down with the cooled down matter as well. And finally, ridge push occurs during the heating portion of the convection cycle. It happens between divergent boundaries, meaning moving away from each other, and it is when hot matter pushes up on the Earth's crust, and gravity helps by separating those plates, creating room for new crust.